algebras. Welcome to Chapter 6, Lesson 2 notes, where we're going to add and subtract polynomials. So, yesterday, or when you last watched, we talked about our vocabulary when it came to polynomials and terms. And so, now what we're going to do is talk specifically about like terms versus unlike terms, which is something that I've actually been saying all year, but now we're going to get into bigger and more examples of this happening, right? So a term, remember, is a number, variable, or a multiplied combo of numbers and variables. And notice I say multiplied, not added or subtracted, which means that whenever you're adding and subtracting, when it comes to terms, if they're not like terms, they end up being separate terms. Multiplying is the only way that you're getting one term. Okay? So two or more terms that contain the same variable, and I'm going to put a little s on the end in case there's multiple variables, with corresponding variables having the same exponent, so raised to the same power, they're called like terms. And this is an important thing to know. We're going to create some like terms. We're going to create some unlike terms. Like terms are things like 3ab and 10ab. Same variables present, raised to the same exponents. Negative 5x squared y and 10x squared y. Same exponents on the same variables that are present. Notice the front number, the coefficient, isn't what's important. It's how many variables, what are the variables, and what powers are they raised to. That's what creates like terms. Okay, so another pair of like terms is x and 4x. Those are like terms. Now, unlike terms would be something like 3ab and 10a squared b. Sure, the same variables are present, but not raised to the same powers. They have to be exactly the same variables that have exactly the same exponents on them to be considered like terms. Okay? Sure, negative 5x squared y and 10xy squared. They're unlike terms. The same variables are present. One of the same power is present, but not on the same exponent, or excuse me, not on the same variable. And that means that they are not the same. Okay, they're not like variables. They could not they could not add or subtract together. All right. Lastly, if you have x and 4x squared, unlike terms, cannot add together. They have to be that x raised to the same power. Okay, so to add like terms, so after you've identified if you've got like terms, right? To add like terms, you add their coefficients, the numbers in front, and keep the variable the same. The coefficient is the amount of that variable you have. That is what is changing when you are adding your like terms or combining them. So when you look at example number 1 and you've got 9x plus 2x, you got 9x's and you've got 2x's, and they are like terms. So how many total x's do you have? 11. Negative 16cd plus 3cd, well, they're the same variables raised to the same powers, so add their coefficients. You get negative 13cd. same variable raised to the same power, add their coefficients. 18 minus 1 is 17 y squareds. That's how many you have. Okay. This is very important. So if you don't understand this, please stop here, go back, and look at these again, because this is one of the biggest deals this year. You've got to be able to identify like terms and combine them. All right? Now, of course, this picture speaks all the words that you need off to the side here, right? Monomial is one term. Binomial is two terms. Trinomial, three terms. And polynomial is many terms. Honestly, we use polynomial to describe even monomials when there is just a single term. We use polynomial to be the general term of talking about terms. See what I did there? But you'll notice that there's these prefixes here: mono, one; bi, two; tri, three; poly, many. You've heard all these before now, okay? But those prefixes are all on a nomial, right? The nomial is the term. Okay, the nomial means term, number. This I talked about in the last lesson as well, but talking about it again because now we can describe our final answers as monomials, binomials, trinomials. And when you hear me using those words, now you'll understand I'm referencing a polynomial with two terms, or I'm referencing a polynomial with three terms. And so as we continue, that's what I kind of talk about, right? All right, so a polynomial is in simplest form when all like terms are combined. Sorry, I wrote real big there, so I'm putting my period at the end down here. When all your like terms are combined, your polynomial is in simplest form. Since we've already learned standard form, I'm also going to expect standard form, okay? So simplest form, standard form, that's how we represent our final answers. Now, adding polynomials is just combining like terms. We don't even technically need a separate thing talking about adding polynomials. We really don't. We just combine like terms. So in number one, where I'm told to simplify 3ab plus 5b minus ab plus 4ab minus 2b, look for the like terms and combine them. So what I like to do is like the same number of underlines under the like terms, and then I add their coefficients up. So 3ab minus 1ab is 2ab, plus 4 more ab gives me a total of 6ab. Done. Now I've got 5b and negative 2b. 5b minus 2b is a positive 3b. We link unlike terms together with plus and minus signs. And that's just the sign of the coefficient in front of the next term is that plus or minus sign you bring. This is a second degree polynomial because 1 plus 1 is 2 for the degree of that front term with a leading coefficient of 6. And it is in standard form because we went with the highest degreed term and then the next degreed term. Okay, that's what I'm expecting. Number two, sum means to add. So this really just means add these two things up. Okay, cool. Again, that just means to combine like terms. Okay, things that are not like terms cannot add and subtract. They just get linked with plus and minus signs. So 3x squared plus 6x squared, those being the like term, gives me 9x squareds. Done and done with those. Now let's add the constants. 5 plus 8 is plus 13 at the end. Simplest form, standard form, right there. Second degree polynomial. It's a binomial because there's two terms. Leading coefficient is 9. All right. Okay, looks like here p squared is the highest degreed term, right? So I've got two of them right here and right here. Let's combine them to be 7p squareds. Done and done. Okay, next degreed term is this negative 3p, and it can't combine with anything, so I just put it next. Done. And then last degreed term is this constant. This negative 3 goes at the end. There you go. Simplest form, standard form, second degree polynomial, leading coefficient of 7. Now, number 4 is where things get a little bit messier. And again, this is typically the only spot we see this stuff in. It kind of disappears after this, but we have to know how to deal with it if we do encounter it, which is why we talk about it. Okay, so let's look at all the u's and the v's and look for like terms. We need to have the same variable raised to the same power for things to be like terms. So what I typically do is the first term I see, I look for where its likes are. So u to the third, v to the fourth. Here's another u to the third, v to the fourth. Here's another u to the third, v to the fourth. Okay. Any just u's like this? Any more just u's like this? Yep, right here. Any more u squared v squareds? No. Okay. So that's the only one. Any more u to the fourth, v to the seconds? No. Okay, so I realize now I've got 4 separate types of terms, and I need to start with the highest degreed term. So I'm going to look for high exponents, right? Well, these guys are 7th degree, and these guys are 6th degree, 4th degree, and 1st degree. So this is where I will start the 7th degree terms. So -5 minus 5, that's -10, plus 8, that's -2 u cubed v to the fourth. And now I'm going to cross them all off. So all the things that had one single underline are all crossed off. And now we'll go to the next degreed term, which is this guy, who has 4 underlines and is the only one with 4 underlines. So I just rewrite sign and then variables with that term, and I'm done. Now I go to the next lowest, which is this one with the u squared v squared. So that would be plus 8u squared v squared. Cross that guy off. It didn't combine with anything. Last terms to combine are like terms, so they can add up. 9 minus 8 is plus 1u. And I don't write the 1 in front because having a single u is the same as writing the 1 in front. Could you write the 1 in front? Yes. I do not. Okay. Again, pause and take that in if you need to. This is what that time is for. Now, subtracting like terms is really just, look, if you've got a negative sign in front of a set of parentheses, it's really distributing a -1. That's it. Okay. And it's because of this situation that we worry about it. So we've got this minus a minus means 3 plus 2. It's really plus a positive. So we just make sure that we distribute a negative that might be in front of a set of parentheses. So it's used throughout, and then once that distributing has happened, that's then the polynomial I combine like terms with. Okay, so in number 1, distribute this negative in front of this parentheses. So now what happens is you got a negative 2x squared, a positive 9x, and a positive 6. And now that's what combines with any other like terms. So our final answer is 3x squareds plus 3x plus 9. So that negative is in front of all of those pieces is what we're saying if it's in front of a set of parentheses. Again, on number 2, distribute. Change those signs. Negative 2x cubed, positive 4x, negative 8. Rewrite like that if you have to, and then go and combine those like terms. So we get negative 15x cubed. Then minus what? 7x x, and then minus 1. There's your final answer. Okay. Positive 10n squared, negative 11n, positive 2. That's what remains here. Now combine your like terms. Okay, so 17n squared minus 3n minus 2. There you go. Now here's where things start to get tricky, and you have to read and be mindful. Subtract 5a plus 3 from 5a plus 4. You need to rewrite. When you see this, it's 5a plus 4 minus 5a plus 3. You need to make sure you're distributing that negative by the right terms and then combine. You get 0 a's and just 1 as your final answer. 4 minus 3 is 1. Subtract 2a to the 5th plus 10a minus 2 from 12a to the 5th minus 6a plus 3. This is the thing being subtracted. So if you want to rewrite right here, this is the thing whose signs change. So notice what I did was I distributed that negative throughout there and rewrote it. Now I can combine like terms. 10a to the 5th minus 16a plus 5 is my final answer. From this, subtract that. So this time the order was correct, but I have to make sure I distribute this negative. I get negative 3x to the 5th minus 4x squared plus 3, and now combine like terms to get 2x to the 5th minus 2x squared plus 4 at the end. Be very mindful of those words with subtraction. That from might mean you have to change the order and reset up and then distribute and then combine like terms. But that's the most confusing part about this piece. I think adding is quite straightforward. It's just combine your like terms together. Subtracting is where things might get sticky. Okay. If you need help with that, do let me know. I'm more than happy to help you with it. Okay. But keep your notes with you. Sorry, I zoomed in. I meant to zoom out. Keep your notes with you as you're doing this so you have the examples and can remember the verbiage that makes that switch happen. Okay? Don't forget, we've got all these vocab words that are mighty important as we continue. Guys, good luck. Let me know if you need anything. Have fun with it. I'll be seeing you.